Properties of convolutions. Properties of convolution. So if we have function f, g and h continuous piecewise, on interval from 0 to infinity, then we have a following property. If we take convolution of f and g, that's the same as convolution of g and f. So commutative property. Second, if we take f convoluted with g, which is convoluted with h, that's the same as f convolution with g and then convoluted with h. Associative property. And the third one, we can distribute addition. So f convolution with g plus h equals to f convolution with g plus f convolution with h. All this property follows directly from the definition of convolution, because convolution is integral and those properties will follow from that. The main property of convolution, which we're going to be using often, is the following one. Let f and g be piecewise continuous on integral from 0 to plus infinity. Then if we take Laplace transform of f convolution with g, that is the same as Laplace transform of f multiplied by Laplace of g. By the definition, Laplace of f convolution g equals to integral 0 to infinity e to the negative st convolution of f and g. Now instead of convolution, we'll write down what its definition. That is integral 0 to t f of t minus v g of v dv. So that equals to integral 0 to infinity e to a negative st. And this one, instead of having integral 0 to t, I want to have integral 0 to infinity. To do that, I will multiply everything by u of t minus v. So f of t minus v, g of v, dv, and then dt. That becomes integral 0 to infinity I'm going to switch order of integration, so we'll write dv on outside and I'll write dt inside. Integral 0 to infinity e to a negative st u of t minus v f of t minus v g of v equals g of v is a constant with respect to t, so I can take it outside. And inside we're going to get integral 0 to infinity e to a negative st u of t minus v f of t minus v dt dv that equals to integral 0 to infinity g of v. Be careful, look what is written here in square brackets. That is Laplace transform of u t minus v f of t minus v dv. So we're going to get integral 0 to infinity g of v. That, using translation in t-axis, is going to be equal to e to a negative sv Laplace of f. And this one is function on s. Because that is a function on s, we can move it outside of our integral. Multiplied by integral 0 to infinity g of v e to a negative sv dv. Now that is Laplace transform of f times, and that expression is going to be Laplace transform of g. And that's exactly what we wanted to get. Laplace of convolution equals to product of Laplace transforms. Example. If I want to find the Laplace of integral 0 to t e to v sine of t minus v dv, if I want to find Laplace of that expression, of that integral, if I realize that I need to find an expression inside is convolution of e to a t and sine of t, if I realize that, the rest is straightforward, because Laplace of convolution equals to product of Laplace transforms, Laplace of e to a t times Laplace of sine of t. So we're going to get Laplace of e to the t 1 over sine s minus 1, and Laplace of sine of t is 1 over s squared plus 1. All that is left, rewrite them together, and we'll be done.